Okay, hello everyone. Welcome to our next discussion. You'll be happy to know this is really our last discussion for the semester. I've got this one and another one, and you guys are done hearing from me, which I'm sure all of you are very happy about. In the last couple of modules, we talked a little bit about climate change and global warming as it applied to flora and fauna, talked a little bit about wildfires. I'd like to sort of continue this discussion on some of the items that you don't really hear a whole lot about. And one that I think, of course, is very, very important. So let me go to the handout here, or the overhead, so that you can kind of get an idea of where I'm going here with this. So something that I don't think we hear enough about is the potential of climate change and global warming as it applies to human health, all right? What I want you to understand here is that there are more deaths from extreme heat than there is cold. One of the things that we have to take a look at is that something that we don't really give much thought to that I think is very, very important is the fact that many people around the world don't have air conditioning. Air conditioning is very much an American thing. It is growing around the world, but many of these cities around the world are much older than the cities in the United States, much older than the United States itself. And there are many places in Asia, you go to Europe and stuff, and a lot of these old buildings simply don't have air conditioning. So a lot of people, of course, are heavily dependent upon opening up the windows. That's even true in some US cities. If you go to New York or you go to Philadelphia, go to Chicago, these buildings are very old. Not everyone there has access to things like air conditioning. So something that you and I may take for granted, a lot of people don't have access to. And so heat becomes a very, very big problem, all right? And so when we look at this, we know that extreme heat is something that is very important to us. You can, in extremely cold conditions, you may be able to get into a shelter. You may be able to build a fire. But what do you do if the temperature is 95 degrees and 90% humidity? Where do you go? Okay. And so heat, of course, tends to be more of a problem for us health-wise than cold weather, okay? So there are some things, of course, that I'd like for you to be aware of here with this, and these are three biggies that I'd like to point out to you. So as we see global warming continue to take place, as we see climate change taking place, there's really three things that are very important for us to sort of be aware of. One, of course, is that you and I can anticipate to see more flooding in areas that are already prone to flooding. This is an image a number of years ago from Houston, Texas. And I have to tell you, if you look at this, and of course you see these signs are getting close to being completely underwater, and you take a look at these houses, this is not bizarre, okay? I'm not saying that it happens, on a regular basis in Houston, but of course, this part of the country, the Gulf Coast, all right, we certainly see quite a bit of that. Around the world, flooding kills more people than any other weather-related event, all right? That's not so much true in the United States, but around the world as a whole. So we know that flooding is a huge problem for us. In these low-lying areas like Houston, like New Orleans, like Mobile, Alabama, but a lot of Indonesia, a lot of Asian countries and stuff, we know that many of these places are at or below sea level. And as a result of that, when they have these massive flooding or these huge weather events, there's really no place for the water to go. We, at least here in Nevada, we're way above sea level, and we are, at an elevation here where at least the water can stay below us in many instances. Not all instances, but in many. So we know flooding is a huge problem. Another issue when it comes to, of course, rising sea levels and more heavier precipitation and flooding is the contamination of water. Now, you have to keep in mind, if you take something like in 2005, Hurricane Katrina, 80%, most of New Orleans sits below sea level. 80% of the city was underwater, all right? And think of all of the oils, all the chemicals, all these things, water contamination. And that's not something that, of course, goes away very easily. A number of years ago, the country of Haiti experienced a very severe earthquake. Unfortunately, many people died. But after the fact is there was a lot of standing water and a cholera broke out, and more people have died from cholera than the actual earthquake itself, okay? The other thing we need to talk a little bit about is the tremendous rise of vector-borne diseases, okay? And it is spelled B-O-U-R-N-E, all right? And that's the rise of vectors. Vectors are insects, they're animals. They transmit diseases from themselves to human beings, all right? These are infectious type diseases. And around the world, we know that vectors are rising in numbers, and they tend to carry disease. Well, if we have more standing water, then that means that's more of a haven for these vectors to actually thrive, okay? So when we look at this, you know, you and I don't deal with malaria in Nevada, but we certainly deal with West Nile virus, okay? And West Nile virus is transmitted predominantly from mosquitoes, but birds also transmit it. And we're the dry state in the country. We don't really think about this a whole lot, but it is a growing problem here in Nevada, okay? So these are some things that we do need to sort of take a look at with this. So as I said, I'll come back to the images here in 1 second. When we look at this, we know that extreme heat is, you know, a leading cause of weather events in the United States. I mentioned to you around the world that flash floods kill more people than any other weather-related event. Here in the United States, it's actually heat, all right? And again, if, you know, we have a heat here in Nevada that we know we can get pretty darn hot in the summers, but we're a very dry heat. And we do have the luxury of many times to go someplace where we can cool off, a shopping mall, a movie theater, you know, school, whatever the case may be. But there are many people in this country that don't have access to this. And of course, if you head towards the Midwest to the Eastern United States, they deal with the humidity issues that you and I don't. So if any of you are familiar with this, of course, you know what I'm talking about. That is anticipated, of course, to get worse. But I do want to show you here something that took place in 2003. And again, it happened again in 2006. And what happened is that if we go to the, or let me go to this, I apologize. Okay, so let me go to this image here. Okay, so I'm trying to bring this up. Okay, so let's go to the current slide here. Okay, so let's see if when we actually look at this, what actually comes out of this is that, of course, we look at something like this, and this is projected. This came out in 2020. I apologize for getting ahead of myself here with this. You'll notice that by the year 2100, all right, we don't have any states out there. We're not looking at Hawaii and Alaska, but we're anticipated to see a rise in heat-related fatalities, okay? And what's interesting about this, of course, which kind of should be alarming, is not only do we continue to see sort of the heat-related fatalities here in the South, but we're anticipating to see a tremendous rise of this within the upper Midwest and the northern tier of this country. Now, this is just a projection, all right? But again, we look at this, we know that this is a potential threat with this. In 2003, I apologize for getting ahead of myself here with this, is that we know that in 2003, Europe was going through just a tremendous heat wave. And many of these deaths, many of the 70,000 deaths actually came from the country of France. And if you're not real familiar with the geography, this is France right here. Here's Spain here. Here's the Great Britain, Ireland. So we got Germany over here, Italy down here. But you notice much of this was centered in France, and they took the brunt of this. And again, it was one of those extreme heat waves that took place. People did not have access to air conditioning, as I mentioned to you before. That's more of an American luxury with this. And people fell prey to this. Sad to say, in 2006, they had another heat wave. 70,000 people did not die, but nonetheless, there were a lot of fatalities with this. So guys, we look at this and we see the rise of heat. We see stronger heat waves, longer heat waves in areas that aren't used to this, that are becoming more prone to it. And so we know that this is a potential problem for us, okay? So anyway, if we take a look at this, one thing that I want to share with you that I think is important for you guys to be aware of is what is commonly referred to as the growth of what are called urban heat islands. Now, I want to point out something to you. It's a little bit, on the side with this class. Most of the world's population is actually now urbanized. That means that there's more people living in more suburban or urban areas than, say, in rural communities. And so we know that, and here in the United States, about 80% of us actually live in an urban area, okay? So when we look at this, I want you to take a look at this graph here, all right, when we look at the distribution of the world's population. And this is going to be important as part of our discussion. So you'll notice here, of course, if we go back to 1950, looks like about maybe 30% of us lived in a city. We make our way up here towards 2020, and you'll notice almost half of us, if maybe not right at half. By 2030, of course, we're approaching that, 55, 60%. But in your lifetime, not knowing your age, but look at by 2050. 2050 is just a short ways down the road, generally speaking. That means that over 60% of us will reside in an urban area. And this becomes what is considered to be, this creates what are called urban heat islands. So I'd like for you to understand that more than half the world's population is urbanized. Now, I want to explain something to you. There is the rise of what are called urban heat islands. An urban heat island, if you look at this graph here, is if you and I were out here in rural farmland, okay, so we're out in the rural community, we don't have a lot of concrete. We don't have a lot of roads, perhaps. We don't have a lot of buildings, all right? It's kind of sparsely populated. But as I start to move from that rural communities and I start to move into suburban and more urban areas, notice how much higher the temperatures actually is, all right? And the reason why this, of course, is we look at this, look at the phenomenal amount of buildings. Now, if you're not familiar, this is New York City. It's referred to as a concrete jungle. But think about if you've ever spent any time in Los Angeles or San Francisco, Seattle, Portland, places like this, or maybe you guys aren't familiar with some of the East Coast cities or Chicago in the Midwest. We know that urban heat islands are growing by leaps and bounds. These buildings radiate heat. They have air conditioners on it there, the heat radiates off the concrete, off the pavement. And so we get these phenomenal, areas that are called urban heat islands. And this is generated by cities, the cars, things of that nature. And I want to point out to you, just kind of going back to this, one of the most interesting studies I ever found is that if you go to New York City and you look across the river, you look at a place called Teaneck, New Jersey. It's just right across the river. And they measure the temperatures in New York City. They measure the temperatures in Teaneck. And it is fairly common in places in months like July and August and September, where it tends to get very hot, very humid, very oppressive. You could have more than a 20-degree difference between downtown New York City and over in Teaneck, New Jersey, which is just right across the river. If you were standing in New York City, you just look over there and you'd see Teaneck. You're in Teaneck, you look right across the river, you see New York City. But that's the difference, and this is what is being generated. So guys, cities around the world are growing. And as temperatures warm, as climates change, and we see more warming, we can anticipate to see a rise in these urban heat islands. And that doesn't bode well for, of course, a lot of people in terms of not having air conditioning, all right? A lot of heat-related illnesses, heat-related deaths, of course, with this. So let's take a look at this, okay? So we know that areas that are wet, we're anticipating them to become even more wet, okay, or become wetter. Places that are dry, we can anticipate maybe drier conditions. But what happens here, of course, is that as we see more intense, all right, precipitation or more intense weather-related events, there's really no place for a lot of this water to go, especially in those areas that, of course, are more low-lying, as you can imagine with this. So I get more, of course, standing water. And what happens here, of course, is that when I see this, okay, with this standing water, I can only anticipate, if you will, all right, I can see more standing water with this. So take a look at this. You might say, okay, well, that's not, a whole lot of water. You can see the house here in the background. All right, you see the trees. But remember, standing water is a nightmare. Standing water is very conducive for the growth of vectors, meaning it's a haven for mosquitoes. It's a haven for ticks. It's a haven for other types of vectors that can reside in that water that are easily able to transmit diseases. A lot of times, of course, if we're in these large urban areas, there's no place for that water to go. The surface is impervious. It's got roads, it's got concrete. It goes down the storm drain. That storm drain backs up. That's a little bit of a challenge with this. So what we do know as we see this, of course, we know that the quality of water, of course, also becomes degraded. A lot of sedimentation, a lot of chemicals, a lot of what are called non-point sources of pollution. This is urban runoff, things of this nature. Now, I want to point out to you as we go through this, and this will lead me to my next discussion with you guys here, and this is kind of where I'm leading us with this, is that keep in mind that when we talk about diseases, and let me just lay this foundation for you in our next discussion, we'll go into this a little bit more detail. So to keep this very, very simple, there are what are called non-infectious and infectious type diseases. Non-infectious type diseases are those types that cannot be transmitted from one human being to another or from a mosquito to a human being. These are things like cancers, diabetes, things of that nature, okay? It's not that we're not interested in this in atmospheric science or talking about global warming or climate change, but we're real interested more in the infectious type diseases, those that can be transmitted from human beings to another human, and maybe more important in the discussion of global warming and climate change, going from non-humans to humans, and these are vectors, okay? So we know that we're seeing a rise in vectors, especially things like mosquitoes. Mosquitoes transmit a tremendous amount of disease. This is where we're actually interested. And what these are called vector-borne diseases, all right? Sometimes it is spelled with a U, sometimes it's spelled without the U, but the E is always there. That's why you've seen different spellings here from with me. The biggest concern are the rise in vectors, all right? Those insects, those bugs, those animals perhaps that are growing because of heat, because of standing water specifically, that is where we become very concerned with this. Here in Nevada, being the driest state in the country, I said to you, we have to be concerned about the rise of vectors. If any of you live in Douglas County, you guys actually have a vector program where in the middle of the night, the county will drive down residential streets and they'll be spraying. Okay, they'll be spraying the trees, they'll be spraying for bugs and mosquitoes. This is the driest state in the country. So think about if you lived in a place like Florida, or you lived in a place like Louisiana and Alabama or East Texas, where it's very, very wet, all right? Standing water is a huge problem. And so we see the phenomenal rise of vectors in places like this, okay? So rising water, standing water is very conducive for vectors, okay? In our next discussion, we're going to kind of build upon this, and we'll talk about some specific diseases and what we're interested in with climate change and global warming, okay? I'll check back with you here shortly, okay? So have a good afternoon, or have a good day, I guess I should say. All right, and I'll be back with you guys soon.